be doing just as you please.
You'll find that you can make each day a better day. You can make each day sublime. I'm buying a Chevrolet. Your dreams will come true. They can do that. Will give you a wonderful time.
The Johns Hopkins Science Review, presented by the Johns Hopkins University and WAAM in Baltimore. This is the Johns Hopkins University, famed for 75 years for its contributions to science and the humanities. Here in its many laboratories, Hopkins scientists are constantly probing into the unknown secrets of science, which, when discovered, will be translated into benefits to be enjoyed by you, the people of America. Each week, we look over the shoulders of today's scientists and catch a glimpse of the results of their research. This week, we will see how a murderer was convicted by microscope. And here is Lynn Poole of the Johns Hopkins University to introduce this week's program.
Greetings, ladies and gentlemen, and welcome to another Johns Hopkins Science Review. During the past year, we have demonstrated many things in the entire alphabet of science, from aeronautics to zoology. Things that are definitely important to you and to me, things with which you and I are connected. But tonight, we would like to explore another phase of science, a phase in which we sincerely hope you will never be connected, but one which is important to you every day. Now, this is the science of crime detection. Now, not crime detection in the romanticized version that you see sometimes on the silver screen and read in magazines. This is science detection using the latest methods of science as it is practiced every day throughout the country. Now, we would like to recreate a scene for you, to tell you a story. Now, this story had its beginnings in a remote section of the town at a little short street only 1 block long, a street up here called Random Street. Now, this is Random Street, where it all began.
It was Friday the 16th on a dimly lighted street on the far west side of town. No one was there to see what happened at first. But later developments show that a middle-aged man was walking down Random Street. Later, it was discovered that he had stopped in front of an antique shop on Random Street, looked in the window a moment, then lit a cigarette. As this middle-aged man turned to go on his way down Random Street, another younger man approached. The older man hesitated as the young man stopped him. They started to talk quietly at first. Then their discussion turned into a heated argument. Then things really began to happen. The younger man hesitated, seemed not to know which way he should run. This was a mistake, because a third person, roused by the shots, looked out of the window and clearly saw the face of the young man and noticed he had a slight limp as he dashed off down the street. The murder was reported to police headquarters at once, and the homicide squad went immediately to the scene of the crime. And only 10 minutes later, another report came in. This was at police headquarters.
few minutes. Two things happened here near Random Street. A murder was reported to the police, and a hit-and-run accident was reported and told over the phone. Now, the police went to work right away. They went to work on these two cases which seemed to have nothing to do one with the other. But nevertheless, the report of the murderer and his description, in addition to the hit-and-run accident story, was reported on the early evening television news, a broadcast that was heard by many people all over the city.
Hello, operator. Give me the police. Yes, hurry. Hello, I heard that news report about that man you want. Yes? Yes, I'm sure it's the same one.
This was all the police had to go on. But they took the young man into headquarters for questioning. They took him in on the grounds that he was a suspicious person. While the police were quizzing the young man, another group of police were investigating an automobile which had been found on the east side of town. Technicians from the crime laboratory were there seeking evidence which might tie this car with the hit-and-run accident reported earlier. First, one took flecks of paint from the bumper. Then they removed clots of blood which were stuck to the bumper. These bits of possible evidence were taken into the office of the Chief Medical Examiner for the state of Maryland, where Dr. Henry C. Frymuth, the toxicologist, was making the usual scientific investigations for evidence.
What we are attempting to do is to determine whether the automobile in question had come into contact with the victim of the hit-and-run accident. In examining the coat, we found a fleck of paint. We also obtained a sample of paint from the automobile. These two samples of paint were then examined in a spectrograph. The spectrograph is an instrument which permits us to analyze the composition of paint samples as a result of burning the paint in an electric arc. The light which is emitted subsequently passes through a quartz prism and is photographed on a photographic plate. The spectrogram which results I have here. This row of lines represents the sample of paint found on the coat. The bottom row of lines represents the sample of paint taken from the automobile. As may be seen, the lines on each of these coincide exactly, indicating identity in chemical composition. Subsequently, the two pieces of paint are placed under the microscope in an end-on position and are examined in order to determine the layer structure. I have a drawing here of the layer structure of these paints as they were seen under the microscope. You may see that the upper set of lines represents the layer structure, 4 different layers of paint found in the paint taken from the coat. We also have 4 layers of paint in exactly the same positions found in the paint taken from the automobile. That is one point which establishes the fact that the car had come into contact with the victim. In addition, we have found on the fender of the car a piece of fabric. We will now compare this fabric with the fabric making up the garment. Here we have a tear in the coat with a piece of fabric missing. The first step in the examination is to make a thread count in order to determine whether the two pieces of fabric are constructed in exactly the same way. In other words, the pattern is the same. Subsequent to that, having found that the pattern was identical, pieces of thread were removed. One piece of thread having been removed from the cloth taken from the fender, another piece of thread from the garment worn by the victim of the hit-and-run accident. I have placed these two pieces of thread under the microscope. Let us now focus on those pieces of thread to determine whether they are identical in composition. What we would like to establish is whether they are made of the same types of fibers, the same colors of yarn, and any other points which would strengthen our chain of evidence. The top thread in this field represents the thread taken from the fabric found on the car. The lower thread is that taken from the coat. As you may see, there are black and white pieces of yarn intertwined in identically the same fashion in the two pieces of thread. Later, those pieces of yarn were dissected and examined under the microscope to find out whether the types of fibers were identical. Such an examination showed identity in the kinds of fibers. That, coupled with the examination of the paint, showed that the car had come into contact with the victim of the hit-and-run accident. Further substantiation of this fact was obtained from an examination of the blood stains found on the automobile. This examination is being conducted by Dr. Russell S. Fisher, Chief Medical Examiner for the state of Maryland.
As you already know, blood was found on the bumper of the automobile. If we can show that this blood matches that of the victim, we have established another strong link in the chain of evidence that this automobile was the hit-run car. Given a sample of blood of this type, a dried stain, there are two general procedures that are done. First, to determine if it is human blood, and secondly, having shown that it's human blood, to determine the type or group of the blood. In order to determine whether a stain is human blood, we use a serum known as anti-human serum. This is prepared by injecting human blood into rabbits who make certain substances in their serum that are capable of reacting with human blood, even in a test tube in the laboratory later. This is such an anti-human serum. The test is conducted in the laboratory by first making up a very dilute sample of the unknown stain. This is such a solution. Then, to a tiny test tube, a small amount of the anti-human serum is added. And then, carefully, on top of that, one lets in the sample of unknown stain, running it in very slowly and carefully so that it lies on top of or overlays your test serum. This is allowed to stand for perhaps 20 minutes and then examined, and I have here an identical sample of the one I've just shown you, made up exactly 20 minutes ago. Let us examine it to see the reaction. Here one sees at the interface between the two solutions a strong white line or white precipitate. This, in a properly controlled test, is conclusive evidence that the stain was of human origin. The next step in studying such a stain is to type it. In order to do this, we use two sera known as anti-A and anti-B sera. They, incidentally, are the same sera that are used in typing your blood if you're going to give a transfusion. Anti-A serum is a serum which will react with A cells, type A cells, and cause them to clump if the two are mixed. Anti-B serum likewise clumps B cells. Another fact that is important in this determination is that a dried stain of type A, if mixed with anti-A serum, will destroy the ability of that anti-A serum to clump A cells. Likewise, a dried B stain will destroy the strength of anti-B serum. The actual performance of the test is made by taking small amounts of these anti-A and anti-B serum and adding to it the dried stain, allowing it to stand overnight, centrifuging it to remove any solid particles of stain, and then testing the sera. Here, in these two tubes, are such preparations that are ready now for testing to see the result of treatment of anti-A and anti-B serum with an unknown stain. We transfer a little bit of the anti-A serum to the test tube, from the test tube to the slide, and then add to it cells known to be type A cells. In similar fashion, we transfer the anti-B serum to the slide, and add to it known B cells. These are agitated slightly to destroy any bubbles and allow the mixing to occur, and then one can observe that coagulation or clumping has occurred in the tube that we know to be anti-B serum. Perhaps a little difficult to see because of the bubbles, but I believe you can see the clumping that has occurred in this tube. If one examines this, then one knows that in the anti-B serum, clumping occurs, which means there was no B substance in the unknown stain. Examine, however, the anti-A serum. It is perfectly clear, which means that there was A substance in the unknown stain, which destroyed the ability of anti-A serum to clump the cells. Thus, the unknown stain was type A. In summary, then, we have shown that the blood from the fender of the car, from the bumper of the car, was type A blood of human origin, and this is strong evidence that the automobile we have seen earlier is the hit-run car.
And Drs. Frymuth and Dr. Fisher came to this conclusion after examining the bits from the fender of this car. But while this investigation was being made, the police were questioning the suspect, the young man that was picked up in the rooming house. Now, part of this investigation was done by Lieutenant Anthony Nelligan of the Baltimore Police Crime Laboratory, a specialist in the study of laundry marks. And that was one of the first things Lieutenant Nelligan looked for when he got the bag from the suspect.
One of the first things we look for are laundry marks and cleaner's marks, which we hope may give us a clue. In this particular case, we are trying to determine whether the laundry marks indicated on these articles are those of the suspect or those of someone else. Here we have a laundry mark. This mark is stamped on the collar of the shirt. Also have another shirt that has the same mark thereon, which indicates that both shirts had been cleaned, same laundry. Now, the next step is to identify these marks. These marks are identified by a side-by-side comparison. We take the sample mark from our files and compare it with the marks, or the mark found on the shirt. And it is easy to see that the formation of both the mark on the collar and the sample mark taken from our files are identical. These articles were cleaned by a laundry in the northwestern section of the city. We went to that laundry and were informed by the manager of the laundry that the shirts in question belonged to a Mr. John A. Smith. Now, that is not enough because the clothing, the rest of the clothing found in the suitcase should be identified to see if they are owned by one and the same person. Now, marked on the pocket of the trousers are these cleaner's marks. These marks in question were placed by a machine. The mark on the pocket is that which has been placed thereon by the owner of the small neighborhood establishment. It's also necessary to examine all the garments to find if they all are of common ownership. Now we see on the pockets of the trousers, the second pair, that the marks found thereon are identical to the marks found on the trousers were part of the suit. Our next step is to identify these marks. And that is done by eliminating the cleaner's marks that do not pertain to this particular garment. In this case, I find that several cleaners in the city have the same mark. Therefore, it is necessary to eliminate the cleaners which marks do not compare with the marks found on the garment. Now, I have found one, and these marks found on the pocket of the trousers and compared with the sample mark in my files indicate that these particular garments had been cleaned by a cleaner located in the southern part of the city. We went to that cleaner located in the southern part of the city and were informed that the clothing were listed to a Mr. John A. Smith. Therefore, both the laundry and the dry cleaning belongs to a Mr. John A. Smith. The questions for us to answer are, who is John A. Smith? What connection does he have in these crimes?
Those questions were quickly answered when the police talked to Mr. John A. Smith. Mr. Smith reported that his automobile had been stolen the night of the crime, that his car had been parked and was stolen from that parking place just 1 block from Random Street, where the crime was committed. Now, this ties the suspect closer because we know that he was in the automobile. He took the bag, went to a rooming house, the bag was found in his possession, and that shows that he was in Mr. Smith's car. Now, the next thing that's going to tie him closer is the gun. Sergeant Frank Mamone, also of the Baltimore Police Laboratory, is a ballistics specialist, and a gun can be mighty important evidence.
This is the gun that was taken from the suspect when he was brought into headquarters. We would like to determine whether this is the gun that killed the victim on Random Street. Now, every firearm has its own specific markings or scratches or factory identification. As you see in the fatal bullet that has been submitted, markings and scratches on the side of the bullet that are caused by the rifling of the barrel. Now, in order to compare that bullet and to examine it, we must first fire a sample shot from the suspected weapon. We fire this weapon into a test box, bullet recovery box, which contains cotton waste to stop the bullet. The first portion of it is soft cotton, where the soft lead bullet will wrap itself in the soft cotton and protect it into the stronger fibers. So we can retrieve it without any other markings on it other than the one that's put on there by the weapon itself. Now, I'll load the weapon and I will fire the test shot. Here we have the test shot that was fired from the weapon. We will take this test shot and examine it microscopically side by side through a comparison microscope and study the scratches and marks that the barrel of the gun embeds into the soft lead. So we take the fatal bullet and we'll place that under the microscope in this stage. We will examine it for the matching lines there. As we see on the left side portion of the evidence bullet, the markings created by a weapon, and the portion of the right bullet, which is the test of the markings of the firearms, indicate that they are both similar, which indicates that they both were fired from the same weapon. Now we have the fatal bullet. We have the test that is fired from the suspect's weapon, and there's no doubt that this is the weapon that killed the victim.
This was the final bit of evidence needed. The end of a trail followed by science in order that justice could be done. The suspect was brought to trial, and even though he refused to confess his crime, the evidence was against him. And he was convicted by microscope.
And this is the trail that ends at the two convictions of these two crimes that were committed near Random Street, convicted by scientific methods. The science of crime detection is a growing science. It's a growing science in which the men in the laboratories, the men in the police departments, the men in your state police departments and national defense are working on all the time to try to perfect the methods that will bring us safety from the sort of thing that you have seen here tonight. Through the use of the microscope, a murderer, a thief, all sorts of criminals have been detected, apprehended, and convicted. Now, the story that you've seen here tonight is a fictitious story, as are the names and the places that were used on this program. But if we were to reach into the files of almost any police department in the country, we could pull from those files examples of the type of thing that you have seen here tonight. And we've only been able to give you, in building this story for you, a few of the series of crime detection apparatus and scientific equipment that are used from coast to coast and from north to south. This exhibition that you've seen tonight was given by the men from the Baltimore Police Crime Laboratory and from the office of the Maryland State Medical Examiner. We want to thank these men for giving so much of their time and demonstrating to us how a murderer can be convicted by microscope. And we hope that you will be with us next week, where we'll be back again to present another program, Feeding the Child.
Scientific thinking on the problems of feeding children has undergone many changes in the past 30 years. From birth and during the early years, nutrition is of the utmost importance. But should children be placed on a rigid schedule for the time of feeding? Should a strict limit be placed on the amount of each feeding? What have been the results of tests of children allowed to determine their own eating habits? Did they feed entirely on a favorite food, or did the child eventually choose a well-rounded diet? Be with us next week when we bring the answers to these and other problems of feeding the child. The Johns Hopkins Science Review is produced by Lynn Poole. Directed by Paul Kane. The associate producer is Robert Fenwick. Associate director, Ed Serro. Art direction by Barry Mansfield. Your narrator has been Joel Chaseman, and also seen on tonight's Science Review, Shirley Bissell. Portions of
This is the Dumont Television Network. Now stay tuned for wrestling.
Dumont, the world's largest organization devoted exclusively to television and electronics. Television receivers.
The finest in modern design means extreme simplicity of lines, based on classical concepts of proportions, with a minimum of ornamentation and a maximum of natural beauty.